Hello everybody. So what we're going to be looking at today are trigonometric equations. Now we can do a whole lot of trig equation type of problems, but it will have to be split up across multiple lectures here. Okay, so this is just going to be an introduction to the topic. Now, in order to do this, we're going to need a unit circle. So I've put a unit circle right here in the notes. You can use any other kind of unit circle that you like if you find one on the cheat sheet or on Google or whatever. But this one will work. Okay, and yeah, and actually before we do that, I would just like to write a couple of values next to it, because if you had a question like this, you would be able to answer it. So you would know, if I say you would be able to say, I hope, answer a question like if sine theta is equal to, let's say, square root 2 over 2, what is theta? Right? You'd be able to solve that question. Right? All you would have to do is you would have to say, well, where is the sine equal to square root 2 over 2? Well, I know that sine is the y value, right? So you would just say, so the y value is square root 2 over 2. And so you look at the unit circle. Where is the y value equal to square root 2 over 2? You'll find right here. And then you're going to find another one over here, right? Those are the two places where the y value is square root 2 over 2. And those would be the angles that you're looking for. So your answer to the question would be simply like theta equals pi over 4, right? That's the first angle. And then the other one would be over here, 3 pi over 4, right? And so you would be able to do that pretty easily. But the only ones that are really easy to get off of the unit circle are the sine and the cosine, right? If you had to read a tangent off of there, it's a little bit trickier. If you had to read off a cosecant or a cotangent or a secant or anything like that, those are going to be more difficult to get, right? Because the values are not written directly on the unit circle for you. And so just kind of to maybe save a little bit of work here, we can just note a couple of things here. Just a couple of facts, I guess. I don't know. A couple of values. Don't know why I'm putting a box yet. Let's not put a box until I have some things to box. Here's what I wanted to say. So, like what happens if you do a 1/2 divided by a square root of 3 over 2? Think about that. If you divide those, you're actually going to get 1 over square root 3. And if you rationalize the denominator, you could also write that as square root 3 over 3. So those are three ways to write the same thing. Why would you care? Well, because if you were doing a tangent or something of an angle like this, you'd have to do y over x. So, maybe that would help you find pi over 6 on your graph if you knew that fact that I just wrote. Another thing that might help you is, well, the other way around. What if you have square root 3 over 2 over 1/2? Well, in that case, you're just going to have a square root of 3. And there's not another way to write it. Okay, are there any more that we want? I think so, because we could also have, what if we had simply 1 over square root 3 over 2? That would be 2 over square root 3, or if you rationalize, 2 square root 3 over 3. So that's a useful value to know. And another one might be 1 over square root 2 over 2. That might be useful to know. That's going to be 2 over square root 2, which is simply square root 2. And I think those are it. Okay, so these are just nothing. These are nothing except values that have been, divided out for you. And maybe they'll be useful to know later on, and maybe they won't. So I don't know. We'll see. I kind of want to box around this. Hold on. That's not how you make a box. That was a diagonal line. That's a box. Let me put it where I want. Okay, good enough. Okay. It didn't exactly box it perfectly, but I don't care. That's fine. All right. So we just have some stuff boxed here. Now we can actually start the topic. So a trig equation, trigonometric equation is what it sounds like. It's just an equation with trig functions in it. So, for example, simply stuff like this. So, like if I say sine x plus 1 2 sine x plus 1 equals 0, for example, that's a trig equation. Or, let's see, like 4 tangent x equals negative 17. Anything like that, and so on. Those are all trig equations. They're just equations, and they happen to have trig functions in them. Okay. Now, something to know about them is that they always have an infinite number of solutions. So they always have an infinite number of solutions. Why is that? Well, think about it. Consider a very simple one here. Consider sine x equals 1/2. That's a trig equation, right? But if you look at the graph of the sine function, okay, not a great graph, but you get the idea. If you look at the graph of that and you say, well, where is the sine of the x value equal to 1/2? Well, you would come up here to 1/2, and if you kind of just drew a horizontal line through there, then every place it hit is a solution to the equation, right? These are solutions. All of these are solutions to the equation. So like this one's pi over 6, and this one's 5 pi over 6. And then you go all the way around the unit circle, and you come back around, and this is like 7, no, not 7, like 13 pi over 6, I think it is. And then like 17 pi over 6, and so on. And again, the point is that they just go on forever out that way, in either direction. So there are infinitely many of solutions. In this section, they're pretty nice to you. They only ask for solutions in between 0 and 2 pi. In this section, they only ask for the solutions. That says sol. Solutions in 0 to 2 pi, right? Which would mean that all they would want here are like 2 pi is right here, so like this section. That's just one revolution around the unit circle. And so that's nice because you can just come to your unit circle here, and you do have 0 to 2 pi is what the unit circle shows. So you don't need anything other than the unit circle in order to do this. Okay, now that's, again, there's in general many solutions, but we're only going to find a couple, like 1 or 2 per problem typically. Okay, so that's basically the idea. Now let's see, how are you actually going to solve some trig equations? Well, let's look at one. Example, they say 4 sine theta minus 8 equals negative 10. And they say find all solutions in 0 to 2 pi. They actually listed it as an inequality. They didn't list it this way. They listed it this way. But that means the same thing, right? All right. So how are you going to do this? So what you do is you take the trig function and just treat it like it's one single unit. Okay? So treat the trig function like it's just one single thing. Right? So for now, we're not going to worry about getting the theta out of the sine, right? Because that's not sine times theta. That's a theta inside of the sine function. So they're stuck together. So just leave it the way it is. So your first step is going to be solve for the trig function with just regular algebra. Normal algebra. All right. So again, you just do exactly what I just said. So you have 4 sine theta minus 8 equals negative 10. So if you were going to try to solve this for sine theta, what you would do is you would move the 8 over by adding 8 to both sides. Then you would have 4 sine theta is equal to negative 10 plus 8 is negative 2. Then from there, you're trying to get the sine theta by itself, so you would divide both sides by 4. Divide by 4, so over 4 over 4. So we get sine theta is negative 2 over 4, which is negative 1/2, like this. That's what you're trying to do. Then you're going to take that result, sine theta equals negative 1/2, and you're going to use the unit circle to find where that occurs. Find the theta where sine theta in this case is negative 1/2. Okay, so you just go back up to your unit circle and say, where is sine theta equal to 1/2? And that's where you're going to need to know where your x's and y's basically, right? Like sine theta is, in terms of the unit circle, what am I doing? Like in terms of the unit circle, the sine theta is just the y value, right? So you're looking for where y is equal to negative 1/2, just where the y value is negative 1/2. So you just come up here and say, well, where is the y value negative 1/2? And I find one right here, and I find another one right here, right? That's where the y value is negative 1/2. So what are the angles? The angles are 7 pi over 6 and 11 pi over 6. So you come down here and you say theta equals 7 pi over 6 and theta equals 11 pi over 6 are the solutions. That's it. Okay. And that's it. It's that easy. So like if I was going to do that on the computer, I just type those in with a comma in between them. I just say 7 pi over 6. Typing it in, you can't see it. I don't know why I'm typing it in, because again, you can't see it. Submit. Oh, amazing, I was right. Never believe it. Okay, so that's it. That's all you're doing in this section is that. The only time it gets hard is when, like I said, you've got like tangents and that kind of stuff. All right, let's do more of these. Example, solve for theta. If negative 10, actually, you know what? Yeah, I'm going to do a cosine. They're doing a sine, but I'm going to do a cosine. Negative 10 cosine theta minus 8 equals 5 square root 3 minus 8. And again, we only want the solutions in 0 theta pi over 2. No, 2 pi. Right, so just those solutions, not all infinite number of them. So what are we going to do? Again, you're going to solve for the trig function with algebra. Not so bad. You got negative 10 cosine theta minus 8 equals 5 square root 3 minus 8. So you're going to add 8, right? To both sides. You're trying to get the cosine by itself. You're going to end up with negative 10 cosine theta. The 8's cancel, and the 8's cancel over there. That's kind of weird that they even have that. Equals 5 square root 3. You're trying to get the cosine theta by itself, so you should divide both sides by negative 10. So divide by negative 10. What are you going to get? You're going to get cosine theta is 5 square root 3 over 10, but 5 over 10 is 1/2, so that's actually square root 3 over 2 when you reduce that fraction, right? Because 5 over 10 is 1/2. Okay, so that's what we were supposed to do. And then we're essentially just going to look up the answer on the unit circle. Use unit circle to find the theta, right? So we're looking for where the cosine theta, which is actually the x value on the unit circle, is square root 3 over 2. So where is the x value square root 3 over 2? So you come here, let's erase these. Where is the x value square root 3 over 2? So I see it right here. And another place where the x value is square root 3 over 2 is down here. Right? Square root 3 over 2, square root 3 over 2. So that's pi over 6 and 11 pi over 6. Pi over 6, 11 pi over 6. All right, that's it, done. I can't type this in because I changed the problem from the Newton, but that's all you're doing, okay? I'm just trying to find where the correct angle is. Okay, let me get a different one. Let me get a different one. All right, come on now. You have a bunch of like basically the same problem in a row. Waiting for it to give me something different. Yay, okay. Now we're into some others. All right, so sines and cosines are what you have to do at first. But after a while, it won't be sines and cosines anymore. So you'll get something like this. So they'll want, they'll say, solve for theta in 0 to 2 pi again. And they give me this, 6 square root 3 cotangent theta minus 5 equals 1, right? Now, again, you don't do anything different here, all right? All you want to do is you just want to say, what do you want to say? What do you want to do? You want to solve for the trig function, right? So we're going to solve for the trig function. So that's the cotangent. So we have 6 square root 3 cotangent theta minus 5 equals 1. So first thing we should do is move the 5 over. So plus 5 plus 5. So now you have 6 square root 3 cotangent theta is, the 5's cancel, so that's 6. All right. Now you're trying to solve for the cotangent theta. So then you should divide, right? You're going to divide by 6 square root 3. So you get cotangent theta is 6 over 6 square root 3. The 6's cancel. It's still a fraction though. A lot of people, when they cancel the 6's like this, sometimes they would just accidentally write square root of 3, but it's not. It's 1 over the square root of 3 because square root of 3 is in the denominator, right? You divided by that square root of 3 there. So we get this. And then we need to look this up on the unit circle, and now that's a little bit harder. So now we need to use the unit circle to find where cotangent theta is 1 over the square root of 3. All right, and so cotangent theta is what sides of the triangle, not triangle, what, in terms of x and y, what is the cotangent theta? It's x over y is what a cotangent is. And then that's supposed to be 1 over square root 3. All right, now this is why I wrote down those extra values there. So let me cut this out here, and we can duplicate it. And let's move this up to where the unit circle is. Okay, move this down. We'll put it right here. Right, so we're looking for where the cotangent, which is x over y, is 1 over the square root of 3. And so I helpfully put these values here where 1 over square root of 3 is right here, right? And that's why I put this here, because you can say, okay, well, if I get 1 over square root of 3 there, then the x over, ooh, that's not what I wanted. Then the x over y here, the x over y right here, should be 1/2 over square root 3 over 2, right? So I'm looking for an x value of 1/2 and a y value of square root 3 over 2. That's how I'm going to get 1 over square root 3 over 2. So I'm looking for x equals 1/2, y equals square root 3 over 2. Where is that? Let's erase these. X is 1/2. Y is square root 3 over 2. All right, I found one. Here. That's where x is 1/2 and y is square root 3 over 2. But there is another answer on here, because another way to get a square root 3 over 2, imagine if the top was negative 1/2 and the bottom was negative square root 3 over 2. Then when you divided them, you would still get the same answer. So I could also look where x is negative 1/2 and where y is negative square root 3 over 2. And that happens, looks like right there. Okay, so those are the two that I'm looking for. So pi over 3 and 4 pi over 3. Pi over 3, 4 pi over 3. Two values. Click, click, submit. Yay. Okay. Now I know that that's not so easy to do, so we're going to do another one of those for sure. Let's erase this though. All right, let's do another one. Example. Again, solve for theta in 0 to 2 pi, and we want 2 square root 3 tangent this time minus 1 equals negative square root, no, just negative 3. All right, and again, what are we going to do? We're going to solve for the trig function. Okay, so we're going to solve for the trig function. So we've got 2 square root 3 tangent theta minus 1 equals minus 3. So we should add 1, add 1. So we have 2 square root 3 tangent theta equals negative 3 plus 1 is negative 2. Then we should divide both sides by 2 square root 3. 2 square root 3. So I get tangent theta is, again, the 2's are going to cancel here, 2, 2. The negative does not cancel, and the square root of 3 is in the denominator. So I have this. Okay? Now we got to use the unit circle. Okay, so what we got is this. I have the tangent theta, which is negative 1 over square root 3. Now, which sides, not sides of the triangle, what is that in terms of x and y? Tangent is y over x, right? So let's take this, duplicate it, back up to the unit circle, try to do this. All right, just like before. Now, again, here we got y over x must be 1/2 over square root 3 over 2, right? Because again, we have a 1 over square root 3, right? We have this thing, 1 over square root 3. The only difference is you'll notice that we actually have a negative 1 over square root 3, whereas this is a positive 1 over square root 3. So that just means that either the x or the y has to be negative, right? Like basically there just has to be either a minus up here or a minus down here. So what we're looking for, what we're looking for is that the y value should be 1/2 and the x value should be square root 3 over 2. But to get the negative, one of them should be positive and one of them should be negative. So I'm looking for y equals 1/2. Where is y equal 1/2? Here's 1. And I'm over here instead of here, for example, because here they're both positive. So if I divided those, I would get a positive square root 1 over square root 3, and that's not what I'm looking for. So, So here's 1, where the y is 1/2. Where's the other one, where the y is 1/2, the x is square root 3 over 2, and they're opposite signs down there. So we got 5 pi over 6 and 11 pi over 6. 5 pi over 6, 11 pi over 6. 5 pi over 6, 11 pi over 6. Those are the two. All right. So we'll do a few more of these, other than tangents and stuff, but same idea. This should be a little bit easier. The only thing that's new here, really, well, two things are new. One, we're using a secant, and also they say we're doing it in degrees now for some reason. So they say solve for theta in 0 to 360 degrees. And then they say -6 secant theta minus 3 equals -15. All right. Nothing's different in the method here, so we're just going to solve for the trig function. As always, so I've got -6 secant theta minus 3 equals -15. We're going to add 3 to both sides. So we get -6 secant theta is -15 plus 3 is -12. Oh, I lost a C here. Then we're going to divide both sides by -6. So divide by -6. We get secant theta is equal to -12 over -6, which is +2. Okay? Then what we need to do is we need to look at our unit circle. Now, something you can do to make this easier, I didn't write out the ones that were useful for the secant. Well, I did, but I just left one off the list here. Let's see if we can do this. This can all go away. Oops. Okay, good enough. Everything can go away. All right. What am I doing? Let's move these a little bit. Move that up there. The one that I didn't do here that I could have was, if you do 1 over 1/2, what's that? 1 over 1/2 is 2 over 1, which is 2. That's what I didn't have on my list here for you guys. Okay. All right. I really do want this in a box. That drives me crazy when it's not. Okay. All right. So what's the point of that? The point of that is that if you come down here, right, we're going to use the unit circle to solve secant theta equals 2. Well, if secant theta equals 2, then what's the secant in terms of x and y, right? That's actually 1 over x is 2. Yeah, 1 over x is 2. You can rearrange that and have x is 1/2 or something. I'm just going to take this, duplicate it. Come on. Why you duplicate? Why can't I drag it? And now I can drag it. Okay, unit circle. Secant theta equals 2, right? And so, again, the idea here is that this is actually 1 over the x value, right? Because that's what a secant is 1 over the x value. And so that's telling you that the x value must be 1/2, right? That's how you're going to get a 2. You're going to get a 2 when the x value is 1/2. So where is the x value equal to 1/2? That's the question. Where's the x value 1/2? And here's one place where the x value is 1/2. And then down here, there's another one where the x value is 1/2. So pi over 3 and 5 pi over 3. Those are where the x value is 1/2. And so if the x value is 1/2, then 1 over x is 2 over 1. All right, so pi over 3, 5 pi over 3. Oh, but we want it in degrees, don't we? They said degrees, right? We're supposed to be doing this in degrees. So we got to do that all in degrees. So come back up here. My unit circle didn't have degrees on it. Others do, but let's just do this. So what are these in degrees? This is 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300. It's ugly, rewriting it. 300, 315, 330, and then of course 360s back up top. All right, so there you go. So what were the ones that we found? We had pi over 3, and we had 5 pi over 3, right? Yeah, 5 pi over 3. So instead of pi over 3 and 5 pi over 3, we should write 60 and 300 degrees. 60 and 300. So this is 60 degrees, 300 degrees. Those are the ones we want. Okay, now we got those mostly taken care of. They do want us to be able to do some on our calculators. Okay, so there's some calculator questions. And actually, you've kind of done these already earlier, but you'll see what I mean by that. So they say, solve for theta in 0 to 360, and then they give me sine theta plus 0.663 equals 0. All right, and we're going to use a calculator. So what you do, you still have to do the first step exactly the same. So you're going to still just solve for the trig function. That's the same. So solve for trig function. Okay, so you solve for the trig function, and you're going to get, sine theta is sine theta plus 0.663 is 0. So we are going to subtract this to the other side. 663 to the other side. So we're going to end up with sine theta is equal to negative 0.663. All right. So this is all the same, but you can't use the unit circle to find your angles this time. What you're going to have to do is you're going to have to use a calculator. Use a calculator to solve for theta. All right, now how are you going to do that? And we did this when we did inverse trig on a calculator previously. So you've got sine theta. So if you have sine theta is equal to negative 0.663, then that means that theta is actually sine inverse of 0.663. So you need to work this out on a calculator. So I am going to try to do a calculator here, like this, and that's an add. That is not what I want. Please go away. Click the X. I am pressing the X. No. Okay, finally. Okay. So theta is sine inverse 663. And so what would we want to do is you'd have to be in degree mode, first of all, which I'm in degree mode. Then I would need the sine inverse, which on this calculator I hit shift, sine inverse, and then I go 0.663, enter, and I get this angle. Wait, that should have been negative, shouldn't it? Did I do that right? Hold on. Yeah, that should have been negative, so that's actually a negative there. So I have to redo that. Negative 663, enter, and I get theta is negative 41. They only want one decimal place, so that's going to be 41.5 when I round that. And there you go. Okay, and that's in degrees. So that's how I get that. But that's not the answer. Okay? That's not going to be your answer because, well, first of all, there's going to be two answers. We've seen that, right? There's going to be two answers, not one. And also, negative 41.5 is not in between 0 and 360. So we've got multiple problems here that we have to fix. And it's not impossible, right? We're going to do it, but we got to fix these issues. Okay, so first of all, negative 41.5 is not a good answer. It's not in 0 to 360, which is what it needed to be. So how do we get that? Well, that's where you have to go back and use what you know about coterminal angles that you learned about earlier in the semester, right? On the unit circle, negative 41 degrees is down here someplace, right? Like negative 41.5 degrees is here. But that's this way. But you could also measure the same angle just all the way around, couldn't you? That's the same angle. So what you do is if you just take this negative 41.5 degrees, and all we're going to do is we're just going to add 360 degrees to it to get a coterminal angle. So we're going to get a coterminal angle. Just by adding 360. So what's negative 41.5 plus 360? I don't know. Let's watch an ad for Toy Story and find out. How do I... Oh, no. Go clear. Go back. No, that's the opposite. Okay. What are we trying to do? Delete all this. I want negative 41.5, and then we're just going to add 360 plus 360. Enter. I have 0 there, but that's okay. So I actually get 318.5, and that's going to be one of my answers. But it's only one of my answers. Okay? Because that gives me one answer. One of our two answers, right? So we fixed the negative 41.5 by adding 360 to it, and so we get back to the same place, but now it's 318.5. Okay, now to get the other angle, what you're going to have to do is you're going to have to say, okay, well, we've got 318.5. There must be another angle on the unit circle that has the same x and y values. Okay, so theta equals 318.5 is a solution. There is one more angle. In 0 to 360 degrees, that's supposed to be a 0. 0 to 360 degrees with the same, what are we doing? Sine value. Why are we looking for the same sine value? Because that's the equation we were solving, right? Was a sine equation. So where's that angle? So I've got this. So again, you're going back to the unit circle. I mean, I could use the one I already drew, but I'm using this one. So we've got this right now. We've got angle down here. That angle is 315. Is it 318.5? All right. So what you need to do is you need to say just, okay, well, we know that, let's see, this up here, right? Sine theta is negative 0.663. So at this angle, we know that sine of 318.5 is negative 0.663. And so we want to say, where does, where else is sine theta equal negative 0.663? And so it's just based on the sine of the angle, the sine, like plus or minus sign on that value, right? There's actually 3 different angles you could consider here, right? There's one right here. There's one over here. There's one down here, right? But out of these, this angle, and this angle, only one of them is going to have a negative sign. So out of these 3, which is going to have a negative sine value, which is what we had. Right? Which one is it? Well, you should be able to figure out that it's this one, right? Because the sine value is the y value. So this is the one that we want. So we want this one right here. And so how are you going to get that one? Well, what you're going to have to do is you're going to have to say, well, that angle right there is going to be, drawing yet another unit circle here, that angle down here, the way you're going to get it is this is still the 41.5, right? But the angle that we want is going to be this angle. So that's going to be 180 degrees plus 41.5 degrees. Wait, is it 41.5? Why do I keep saying 41.5? Oh, because this is 41.5. Okay. So that's what it is. So that one is 180 plus 41.5, which I can do that. That's 221.5. All right. So then my final answer is going to be 220, what is it? 1.5. And what was the first one I came up with? 318.5. And then just to hopefully figure it out, let's see here. So just to demonstrate, if I clear this all off, if I do sine of 221.5, I get that negative 662. Negative. And if I do sine 318? 318.5. I get the same negative 0.662. Same thing, right? So there's two angles. And so you get that one based on like the idea of coterminal angles and what quadrant does. Is there another angle with the same sine or cosine value, that kind of thing. All right, let's try this. Let's try another one. I'm sure that was confusing. All right. Okay. Example. 7 cotangent theta plus 3 equals 0. And we're looking for solutions in 0 to 360 again. And we're going to use a calculator. We can see all the answers are decimals, so we're going to use a calculator. So what do? Solve for the trig function. That's the easy part now, right? So we have 7 cotangent theta plus 3 is 0. Going to move the 3 over. You get 7 cotangent theta is negative 3. You divide by 7. You get cotangent theta is negative 3 over 7. Okay. Now they're making this hard on us because we need to solve this on a calculator. Okay, but the problem is that we don't have an inverse cotangent on your calculator, right? So what you have to do is we only have sine, cosine, tangent on the calculator. So we got to rewrite this in terms of sine, cosine, or tangent. So what you actually have to do is you have to say, well, cotangent theta is negative 3 over 7. But a cotangent is actually 1 over tangent, which is negative 3 over 7. And then just flip these both upside down. So 1 over tangent will become tangent over 1 is going to be, instead of 3 over 7, it's going to be 7 over 3 negative. Okay, and then finally we can do our inverse. So we're going to get theta is going to be tangent inverse negative 7 over 3. So we need a calculator for that. We're still in degree mode, so shift, tangent inverse, negative 7 over 3, enter. Here's my angle. Negative 66.8. They did the same thing to us, I see. They gave us an angle we can't use because it's not in between 0 and 360. Usually, not usually, but they could have, the first one could be in 0 to 360. It just didn't happen either of these times. All right, so we used a calculator to solve this. Now what are we going to do? Well, now we have to get the angles actually where they are. So make this a little, maybe we can do this a little bit better this time. So first of all, negative 66.8, where is that? That's down here somewhere, right? Still in the fourth quadrant down here. So we got theta equals negative 66.8 degrees. Now, let's see if we can put both of the angles we're looking for here on here. So the two angles we want are going to be as follows. I'm going to draw 2 more unit circles. So I guess I'm going to draw it and then redraw it. Okay, so there's a little unit circle. And then there's another little unit circle. Okay, so first of all, one of my angles that's the same as 66.8 is going to be this angle around here, right? And how am I going to get that angle? It's going to be negative 66.8 degrees, and then I'm going to add 360 to get that one. That's how I'll do it. What's that? You need a calculator. Negative 66.8 plus 360. 293.2. That's one of my angles. Now, my other one, that's one of them. Now, my other angle is going to be in quadrant 1, 2, 3, and 4. So what you want to know is like which two quadrants are the tangent negative in, right? Because we have so in the first quadrant, all are plus, right? All of them are positive in quadrant 1. And in quadrant 2, it's all, the sign is positive, but the cosine is negative. In quadrant 3, a smart trig class, the tangent's positive, and in the fourth quadrant, only the cosine is positive, right? But we're thinking specifically about what trig function here. The trig function is tangent, right? Well, it was cotangent, but we turned it into a tangent here. So tangent. So in quadrant 4, we know that the what was true there? The cosine was plus and the sine was minus, right? And that's why we got a negative. And also in quadrant 2 over here, it's opposite. The sine is plus and the cosine is minus. So the other quadrant where the tangent is negative is quadrant 2. So the angle we're looking for is in quadrant 2. So it should be up here. This angle, that's the other one we want. Now, how are we going to get it? And that's a little bit trickier. This angle right here is that 66.8. Okay? So if you're going to calculate the purple angle there, if you're going to calculate this angle, then the way you would have to calculate it is it's going to have to be, you're going to have to take the 180 and then minus the 66.8 to get that angle. Oops. 113.2. That's that one. Okay, so what are we going to do with that information? Well, we're just going to write our answer. So our answer is simply solutions are $113.2, 293.2, and that's it. All right. It does. I mean, we should, be okay with the fact that you can check your answers on a computer, right? Like 7 cotangent theta plus 3 equals 0. if I go to Wolfram alpha here, 7 cotangent, I'm not going to do theta, I'll just put t. Is it plus 3 equals 0? Is that it? No answers? Awesome. Thank you. Really appreciate that, Wolfram. See if it knows what I mean. Nope. It does not. Nope. Useless. Is that, did I actually type it in right though? Let's see. Yeah, 7 cotangent theta plus 3 is 0. We might have better luck with Symbolab here. Let's just try it. I mean, Wolfram alpha can definitely solve these. It's just choosing not to right now. What do we have? Let's see. 7. Oh, right. Cotangent. I need a variable. I'll use x. I did type x, but okay. Everything happens bad here. That's why like when I type a button, it doesn't do it. It waits and it does it afterwards, like a couple keystrokes later. So that's the problem here. Okay, so it solved it. I'm gonna say in degrees, see if I can influence that. I don't know if it'll understand that. Maybe. All right, so subtract 3 from both sides. We did that. Divide both sides by 7. We had cotangent x is -3/7. It solved it. It did arc cotangent. We didn't have an arc cotangent. That's why we used inverse tangent. And yeah, they won't give us the answer in degrees. Well, that's sad. I guess they did give us the 113.2. Actually, they did do it, right? They did give us the answer here, because this says 113.2, which is one of our answers, and then they say plus 180 times n. So one of them is 130. So according to this, one answer was 113.2, and the other one was 113.2 plus 180. And so that's the 293.2. So Symbolab worked better there. Symbolab worked better than Wolfram alpha for this, but they're both kind of a little bit tricky to make it do what you want here. I have to close Notability because I left it and the lag is bad. All right. Submit. Okay, I think we're done with these. Those are a little bit tricky. Come to office hours for help if you need to. You only got to do about 2 or 3 of those on the homework. And that's about it. All right, so good luck on your homework. This is an hour and 5 minutes, makes up for the other 20-minute lecture. Okay, well, see you next time.